ahead of time, overviewing network security and the history of computer networks, which actually started a long time before the internet came into being. So that's where we're headed. So let's next ask ourselves a seemingly simple question. What is the internet after all? And of course, the answer to that depends very strongly, of course, on who you ask. And I thought I'd start off with just a clip from a BBC comedy that I just finished binge watching that addresses this question.
What is it? This, Jen, is the internet.
What?
That's right.
This is the internet. The whole internet.
Yep. After I learned of it so that you could use it in your speech.
It's so small.
That's one of the surprising things about it.
Hang on. It doesn't have any wires or anything.
It's wireless.
Oh yes, everything's wireless nowadays, isn't it?
And of course, if you ask kids, you can always get some amazing answers as well.
It's sort of like a robot in your house that does lots of things and everything for no money or anything. You know.
And then there are some people who sometimes mistake the internet, which is really an engineered artifact, like a roadway or a telephone network, for the people who use the internet. As in this recent headline here from the Washington Post, as if the internet is some thinking entity. But we're engineers, and so let's take an engineering view. And here, we can take two viewpoints. Our first take here is going to be very much a nuts and bolts approach. If you're going to tell me about something, tell me about the pieces. What are the components of the internet? Let's begin at the edge of the network and work our way in. At the edge of the network are the devices that internet users like us use to connect to the internet. There are literally
Here is a key concept. What is network edge? What is network core? And what's the functionality of network core reasons? That's some of the key things.
Mine in less time with Slack. Type it out.
I'm talking about protocol layers. So let's next ask ourselves a seemingly simple question. What is the internet after all? And of course, the answer to that depends very strongly, of course, on who you ask.
It's sort of like a robot.
So let's take an engineering view. And here, we can take two viewpoints. Our first take here is going to be very much a nuts and bolts approach. If you're going to tell me about something, tell me about the pieces. What are the components of the internet? Let's begin at the edge of the network and work our way in. At the edge of the network are the devices that internet users like us use to connect to the internet. There are literally billions of devices connected to the internet. We'll often call these devices hosts or end systems. And there are tons of different types of devices that can be connected to the internet. Of course, there are computers, our own personal computers, computers in data centers, as well as smartphones connected to the internet. We've got internet-connected gaming and media streaming devices in our home. We've got digital personal assistants, security cameras, energy monitors, appliances like refrigerators, washers, dryers, picture frames, and even your mattress can be connected to the internet. There are personal health and fitness devices and human augmentation devices like AR/VR glasses. Vehicles are also connected to the internet. For example, your car, Well, not mine and maybe not yours. This is a Tesla. There are trucks, scooters, and bikes connected to the internet. And one of my favorite devices of all time, and actually the oldest of everything that you see here, is a toaster that's connected to the internet. And it downloads the weather forecast and burns that forecast into your toast. This was actually a master's project in the early 2000s at a university in the UK. And there are many, many more types of devices. And really, for anything that's digital, there's probably some value in connecting it to the internet. And for other formerly, say, analog devices like bikes and scooters, giving them a digital footprint and internet connectivity enables new types of use. Moving deeper into the network, we find the devices that make the network actually a network. What we'll call packet switches that forward packets, chunks of data, between each other and between hosts and devices. We'll see that there are two types of packet switches, routers and switches, and we'll learn a lot about these. And then there are the numerous communication links that interconnect the routers, switches, hosts, and systems. And finally, these links, routers, switches, hosts, and devices are all assembled into networks, each of which is owned and operated by some entity. For example, here on the UMass campus, we operate our own campus network, and this UMass network is different from the Internet 2 backbone network that connects us to networks on other campuses. And it's really the existence of these multiple networks that gives rise to the saying that the Internet is a network of networks. And as we'll also see again and again throughout this course, the sending and the receiving of information among routers, switches, hosts, and end devices is going to be controlled by protocols. Everything that happens inside a network is governed by protocols. Protocols are everywhere in a network. Yes, this is a course about principles and practice of networking. It's also a course about protocols. Because protocols describe a standard way of doing things, there needs to be a body that defines these standards. For the internet standards and internet protocols, that defining body is known as the Internet Engineering Task Force, or IETF, and their standards are known as RFCs, requests for comments. Well, that's a very nuts and bolts approach to what the internet is. And the second way we can answer this question is really by taking a more services point of view and to think of the internet as a platform upon which all of these wonderful applications can be implemented. As a service platform, the internet provides an interface that applications can use to send and receive information to each other. And that, in a nutshell, is really what the internet's all about from a service perspective, the delivery of information from one point in the network to another. Now, all those internet applications residing at the endpoints can be incredibly complex and sophisticated. Imagine that by talking into your control for your TV, a streaming movie starts appearing on your screen. Can you imagine all that goes on in the applications to make that happen? But that application level complexity sits on top of a basic service infrastructure to simply deliver packets from one location to another. All that computing happens in the applications. Is that part of the internet? Well, yes, in some ways, as we'll see, but we'll be focusing more on the information delivery aspects of the internet than on the structure of those sophisticated distributed applications. But we'll cover a bit of this latter topic as well when we cover the application layer. Well, I'd like to wrap up here by coming back to this notion of protocols. And I said the internet is all about protocols. So what is an internet protocol? And really one of the easiest ways to think about internet protocols is to first think about human protocols. You know, I think humans execute protocols all the time. Here's an example of a protocol. It's what I call the "what time is it" protocol.
Excuse me, do you have the time?
I'm sorry. Do you have the time?
Excuse me, do you have time?
Excuse me, do you guys have the time?
So what's the protocol here? The human protocol for asking the time is one person says, "Oh, excuse me, do you have the time?" And the second person then looks at their watch and responds with the time. We see here there's a request and there's a reply. Now, you might think, what are other human protocols? Well, here's a good one that I always like to use when I've got students live and in class, and it's called the question asking protocol. So the professor says, Are there any questions? Professors love to get questions, right? And if you're a student, your part of the protocol then is either, look down at your notes because you don't want to ask a question or look up at the ceiling, or if you've got a question, you raise your hand, right? And then the professor says, oh, okay, great, I've got a question. I love questions. The student asks the question, and then the reply comes back. There you've got a multi-step question and answer human protocol. So why don't you pause me for a second and just think about what other human protocols can you think of?
Students with ADHD save 10 hours studying with this Chrome extension.
But no, by all means.
Well, hopefully you've thought of a couple of good human protocols. So for the protocols that you just thought of, and the protocols that we talked about before, the question-answer protocol and the what time is it protocol, what are the common things that we see in these protocols? Well, there are specific messages that are sent, in the case of humans, things that are said, and there are specific actions taken when the other party receives those messages. And computer network protocols are completely analogous to these human protocols, except that it's networked components, applications, host router switches, and links that are exchanging messages and taking these actions as dictated by a network protocol. Let me give you an example. In the human what time is it protocol, there are two distinct phases. There's the greeting phase, where you talk with me, and then there's the request phase, what time is it, and the response. And as we'll see shortly, that's exactly analogous to protocols used on the web. There's a connection request phase, followed by a request response phase. And so with this as background, we can already come up with a pretty serviceable definition for network protocol that we see here. Protocols define the format and the order of messages sent and received among network entities, as well as the actions taken on message transmission and receipt. Okay, well, that wraps up our introduction to the introduction. And what did we learn here? Well, we actually addressed two technical things. We talked about the question of what is the internet. Remember, we started at the edge and we worked our way in. And we also talked about the notion of what is a protocol. Now, in the next section, we're going to start taking a look more at this nuts and bolts type of approach to answering this question, what is the internet? We're going to start at the edge with the devices we talked about a little bit earlier, and then work our way in.
Guys, if I ask you now, what is the internet? What would be your answer?
Network of networks.
Yeah, basically, this equals a little bit more information, right? Because the internet we cannot say it's one big network. But basically, think about Parview has plenty of network, right? Since this building, we have our own network. First, we have multiple local area network that we need to connect together, right? Then Parview need to connect with other network, makes sense? We have all kinds of different layers of networks. Then we connect them together. In that sense, because network of network, in that sense, make like if Arjuna come from China, right? So if I want to, like for example, the China currently, remember, we used to using the telecommunication network call, actually using the phone network. But now think about your guys, when you make a call, of course we're still using our cell phone, right? But even the cell phone part, did it really actually all go through the wireless cell phone network? Not necessarily. Many of the phone calls also went through the internet. The reason I think about the China is every time I call my mom, actually it's going through the internet part. Makes sense? So the point here is, think about, they already mentioned the network, we have a network core concept, right? Then we have the network edge concept. So network edge, we have all kinds of different hosts. We have all kinds of edge devices. Like currently the IoT is getting popular, right? Even the smart devices need to connect to network in order to be useful. If they are not connected to network, if they are isolated, typically they are not that useful, right? They are useless, right? Even the sensor, when they collect information, they need to transmit those communication to certain kind of the hub, then the processor and so forth. Makes sense? So think about it. The edge, huge quantity of devices. Then we have all kinds of network. Then the internet is playing the role, is connect all the network together. Then make the sense like feel is everybody can talk to everybody. Make sense? Right? That's from one way to think about what is the internet part. At least that answer will be a little bit better, but still plenty of material is in there, right? That's basically then network. Later we have a detailed explanation regarding the network edge part, right? Makes sense? We have the edge, we have a host, different all kinds of the host or edge devices, right? There could be all kinds of different devices, right? Even think about you have the smartwatch, they all need to connect it there, right? Everything, okay? Then think about the core-wise. In the circle, what is network core? The author in the video, they mentioned what? All the packet switches, right? But the packet switches, typically we have what kind of packet switch? Could we have routers or switches, right? Right? Who have the basic feeling? What's the difference of routers and switches? What's the function of routers?
It's more sophisticated than switch, right? Router is more sophisticated than switches. The switches,
That's right. So switches typically switches is only work to a basic layer. So typically it's work in the local area networks, run to the physical layer and the data layer. And the routers typically works to one network layer, right? Makes sense? They need to collect all the network together. Makes sense? That's routers wise. That's some kind of unit of routers and switches. Then when we move on to network layer, we'll talk a little bit more regarding to what is routing, right? How to perform the routing part. That's the main function for the network layer. But you need to know for the network core, think about it. If I want to talk to my mom is in China, I'm here. It's far away, right? Have you thought about how many hops I need to go through to actually make the call, right? Each hops, what does it mean? It's each routers. They need to pass on all those data packets, go through there. Make sense? That's some of the thing I want you to think about. Because before you come to this class, typically we are thinking things like just a typical user, right? As long as it works, doesn't matter. But when you're in this here, you should have the mindset is, I need to know a little bit why and how part.
Yeah.
That's the mindset you need to change a little bit. Make sense? Okay. That's talk about the network core. Then eventually, right? For example, you're using the Wi-Fi to connect to the internet, right? In that case, how does Wi-Fi work? It's using the wireless, using which kind of frequency, right? Make sense?
Yes.
If I go to my office, typically, I still have a really old computer. I still like the Ethernet part.
Yes.
Then I will use the wired part. Make sense? I think it's kind of, so the basic that will be related to different communication links. Make sense? Could be wired, could be wireless. If somebody like, I need a little bit of privacy, I live in nowhere, I build a good house, but no ISP want to provide the internet service to me, right? Then you can use Elon Musk's satellite service. In that case, point is communication link use satellite service. That's another communication link. Makes sense? So that's basically different communication link will be more into which layer category as physical link. Makes sense? How do you connect to the internet? Then when you have a using different technology, different communication links to link to the internet, in that case, the characteristic might be different. Like I mentioned, if you are skiing in nowhere, then you get a storm. Using the cell phone, using the cell tower, right? Then your transmission bandwidth transmission rate is not that high, right? That's why the application you can access, if you are in that specific case, you do not want to watch YouTube videos, right? Make sense? You only send a text to do something because you have a limited transmission rate. But you are here, if you're using the Ethernet or using the Wi-Fi, you have a decent transmission rate, then you can pretty much do everything, right? Makes sense? That's basically related to different communication links. You have a different transmission rate, so on and so forth. Make sense? Okay. Network, okay. I think now you guys have a better what is network protocol, right? Then for each different layer, we have different network protocols. We learn all kinds of different protocols. Okay. Then talk about different organization. Sometimes, for example, if you want to name, we will mention some network protocol. For example, HTTP was in order to, when you want to access serve the internet, it's HTTP mostly based, right? If you want to know a little bit more about HTTP, I can refer to, if you really want to know, typically you don't need to, okay? Really want to know, for example, I need to do some kind of network programming. I need to get some details about those specific protocols, right? You can check corresponding RFC in there. Makes sense? Each protocol, they are associated have their RFC corresponding standard there. Okay? In order to get corresponding request for comments, actually this is already the network standard. The process to get this RFC typically is you have some proposal. You first have the IETF draft, then they discuss, then become RFC. Then everybody will follow the standard. That's regarding to the internet standard part. Okay, I think this we already covered. Move on. Next chapter, we will talk a little bit more regarding to the different applications, right? So in that sense, from this chapter, you might sometimes ask yourself, for the different applications, because all those applications become really popular, like email, we check the email all the time, right? Think about the Zoom part. For example, sometimes Monday, we got something. We might say, like instead we can have a Zoom classroom, right? For those, what's the corresponding network application protocol or requirement in there? That's something you need to start to think a little bit. For example, you guys watch TV, right? We used to watch TV, it's TV, right? We have antennas and so forth. Now, how do you guys watch TV? Netflix? Streaming, right? All kinds of streaming. What streaming service you are using? Maybe, yeah, if you're a household, possibly your Netflix, right? Yeah. Or like I use DirecTV for so long. Even now, I'm hesitating because I barely watch. I'm paying quite a lot to each month. Netflix, think about Netflix recently is really popular, right? Then, next chapter we may talk a little bit about Netflix. Then ask yourself, how Netflix work actually? Make sense? How this kind of process work? Okay, that's the thing. That's some kind of popular applications in there. Then in next chapter, you ask, for example, how does email work, right? Right? When you access doing this searching part to access the internet, HTTP, how does HTTP work? How does email work? That different application, ask yourself, actually what's the related process in there? That's the first step. That's the application layer, top-down approach, right? Then the next thing you want to ask yourself is, that's the application layer. What's the relationship of application layer and the layer below it, which is, guys? Transport layer, right? So what's the relationship with the application layer and applications, what kind of requirement that application ask or demand for the lower layer? Make sense? In that case, for the lower layer, you guys already in your mind already know for the transport layer we have what? TCP. We also have UDP, right? Right? What's the difference there? What kind of application should be supported by TCP? What kind of application should be supported by UDP? Make sense? The layer. So far, after today's class, you should already know the 5 layers. Make sense? Transport layer, application layer, transport layer, network layer, data lake layer, and the physical layer. The order is important, right? And the layers, they need to connect to each other and collaborate in order to make the computer network work. Make sense? Make sense? Each layer, what's the basic functionality there? And each layer, they also have the corresponding requirement. If I have this application will demand which layer to support that. Make sense? Just think about those. Just using a big picture view, start thinking those questions. Okay? That's the because this is first class, right? Start thinking, then later on this will become a little bit easier. Regarding to the protocol, I think the video already did a good job, right? Yeah. Who heard about Wireshark? Actually, Wireshark is a free application. You guys can download it. Okay. Then Wireshark actually, when we actually access the internet, every time you have no idea what kind of package actually going through. Okay. If you download the Wireshark, actually you collect the traces. You will see plenty of data packet. In order to, for example, you want to check your email. Before you check your email, you start to catch those traces. Then later on, you get maybe a little bit, then you stop. You will see how many digital packets already went through in order to support those applications. Make sense? I hope you get those kind of feel. And I remember if I talk to you, hi, you answer me. Similar case, in order to make the network, all those applications work, plenty of digital data packets are passing through. Okay? And those things are related to protocol. You might want to play with it. Okay? Remember the Wireshark, download, watch a Wireshark review, then get the free application, play with it. Then in that case, when you learn different protocol, when you then play it yourself, you will have a much, much better feeling. Okay? Then you will also, when you catch those kind of traces, you will see many different names because we only talk a limited network protocols in the class because we have limited time. Actually, they have plenty of other network protocols there. Eventually, if you want to work in this area, so many different network protocols make sense. Okay, play with it. I will not, because graduate course we have limited time. It's yourself, if you want to learn, just to get it. So it's free. Yeah.
So how do you spell that?
Wireshark. 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 Okay. Think about it in this case, right? Sometimes we want to access the internet. We don't know. When you play the Wireshark, you will see that those kind of packets passing through, those kind of request and reply kind of flow. Make sense? Right? At different layers. Just get the feeling because it talks about the protocol. So many different things are defined in the protocol. This is a good definition. Protocol defines the format, the order of messages sent and received among different network entities. So how many messages passing through? For each message, what is the format? What's in the header? How many header information in there? Make sense? Also, sequence is important. For example, for the TCP, when we move on to transport layer, we have TCP, we have UDP, right? What's the difference of TCP and UDP? Because that's a different information in there. Make sense? Right? That's basically across all the keyword. how many messages you send through, and for each message, what's the format? Because think about your computer, it's a digital device, right? Your computer only knows zero and ones. They are not like a human. Humans are very flexible. If I cannot hear you, oh, what's your name? May I say it quick? Could you say it again? But the network computer is all 0 and 1, right? We need to really start where, end where, what is this, this field need what kind of information, following what kind of format. We need to define it very clearly. All those should be included in all the protocol. Make sense? It's kind of very tedious, but they need to be very clear in there, okay? This I already mentioned. Network protocols is really, really important, right? When you're learning networks, it's equivalent to learning all kinds of different network protocols. Make sense? Also mention, emphasize the concept. This is I borrowed from another professor, okay? So in that, you already see what? 5 layers, right? Physical layer, data link layer, IP layer, transport layer, and application layer. You already see plenty of names in there, and each name is associated with one network protocol, right? Like application layer, HTTP, we're trying to browse the internet, right? And DNS is louder. Domain name service, right? Louder. With small class, every time remember louder. And the BGP related to routing part, right? And the TLS that's related to security, so on and so forth. The UDP TCP is transport layer protocol we already mentioned. And we have a narrow waist, right? That's a network layer, mostly is IP based, right? Although IP, we have IP version 4 and version 6. And then data link layer is dependent on what? How do you access the internet, right? If it's Ethernet, you have the cable there, or 802.11 is if you have the Wi-Fi part, or SDDI is a fiber part, DSL digital, Somehow we're still using DSL to access the internet, right? Some may be using the cable, but different access technology later on we'll talk about. Then physical layer, define more details, 0 and 1s, each frame, how does it start, so on and so forth. Okay. Just to give you a little bit of sense regarding like each different protocols associated with each different network layer. Make sense? Okay. Actually, this one is a little bit old. Now, you guys know what is internet, right? What is protocol? Then next 2 sessions we will talk about We'll talk about the network edge, the network core, okay? For the network edge, let's hear what the authors say. No break, we can get home a little bit earlier. You guys okay?
No, we're going to look at what's happening at the network's edge, and we're starting at the network edge, well, because that's what we're familiar with. It's what we see, it's what we use every day. We're going to cover 2 topics here. We're going to start off by covering access networks. The access network is the network that connects the edge device, those amazing edge devices that we saw in the previous video, into the first hop router into the larger internet. In some cases, an access network connects a network itself, say a home network, into this larger internet. And then we're going to take a look at physical media. We'll take a look at the
access network. Access network network is more related to physical layer, data link layer, right? Then the physical media more related to physical layer. Sometimes might be cross there. And actually, think about along the years, when we talk about network is getting more and more important, right? One of the key change is in the access technology, right? Make sense? When you actually can access a network, also the transmission rate is getting higher. That makes the network more available. Then the application it can support is getting better, right? Make sense? That point here is access technology actually is really, really important. If your network rate, transmission rate is not high, think about a long time ago when we first, long time I got my first CCNA certificate at that time. If your speed is like only 1 point something megabit per second, can you access doing lots of multimedia application? Possibly hard, makes sense? So all those technologies related, because we passing through that barrier, we got a higher transmission rate that can support more advanced or complicated applications. That basic, at the same time, like your cell phone, those devices also getting more and more complicated. Everything's related. That makes the internet more accessible, and the application is more and more complicated. Okay,
copper wires, the fiber, the radio that's actually used to transmit bits from the input side of a link to the output side of a link. Now, to get started, let's remember the broader context. Well, you see our graphical depiction of a network over here on the right. In the last video, we talked about all of the amazing devices at the network edge. Computers, smartphones, cars, and cool home and personal devices. We noted that these devices are sometimes called hosts because they host or run network applications. A host might be a client that requests and receives a service, or a server that provides a service. And we'll see in Chapter 2 that client and server have very precise meanings in a networking context. In the last section, we also talked just a bit about access networks and physical media, and that's what we're going to focus on here in this section. And we also talked about the network core, a set of routers that are interconnected to form a network, and we also talked about how these individual administratively scoped networks are interconnected to form an internet. And so that's the big picture context that we're starting with. So what we want to focus on here are access networks. It's the network that connects the end system, the host, the device, into the larger global internet. It's really that network that connects this device to its first hop router on a path from source to destination. And we'll see that there are basically 3 types of access networks. There are residential access networks, there are institutional access networks that are operated by a company, by an educational institution, by a municipality, and then there are mobile access networks that are operated by cellular access carriers and also Wi-Fi networks. And as we're talking about these 3 different types of access networks, you might want to keep 2 things in mind. First, what is the bit transmission rate over that access? That is, how fast is that network? And also, to what degree must one user share that network with other users? So let's start our discussion of access networks close to home. Well, actually in our home, by first looking at cable access networks. As shown in this figure here, in a cable access network, I have Comcast cable access. For example, in my house, a physical cable connects multiple homes to a single cable headed over here on the right. The signals to and from these houses are sent on the cable at different frequencies. Signals sent at different frequencies don't interfere with each other, sort of just like FM radio. With FM, different stations can transmit on different frequencies, and we tune into the frequency that we want. Cable access networks are based on the same approach, known as frequency division multiplexing, or FDM. But there are only so many frequencies, and so cable users also often have to share a frequency with their neighbors. We'll cover cable access networks and their standard, known as DOCSIS, when we get to Chapter 6. For now, relax. The idea is to get the big picture here, and we'll save the details for later. cable access networks are typically asymmetric, meaning that they're designed to transmit data faster in the downstream direction to the home rather than upstream from the home. And this asymmetry reflects the fact that we tend to be more consumers of data than producers of data. Typical cable transmission rates are 40 megabits per second up to 1.2 gigabits per second in the downstream direction and 30 to 100 megabits per second upstream transmission rate. And of course, as the saying goes, your mileage may vary, and of course your modem will often typically rate limit how fast you can send and receive. Basically, you're getting what you pay for. And note again that the cable network is a shared network. It really is just a shared wire that you can see often strung up on the telephone poles. This means that if you and your neighbor are sharing a frequency on the shared wire and your neighbor's blasting away, transmitting and receiving a lot of data, that may be eating into the amount of data that you're able to send and receive. The second major type of residential access is what's known as digital subscriber line, DSL. DSL networks use the existing phone line, sometimes called a twisted pair because there are two copper wires that are sort of wound around each other that used to, or maybe still do, carry phone service to your home. These DSL wires connect you directly to what's called a central office, so you're not sharing transmission capacity or bandwidth with your neighbors between yourself and the central office. Now, like cable networks, DSL lines are also asymmetric, with a 24 to 52 megabit per second downstream transmission rate and a 3.5 to maybe 16 megabit per second dedicated upstream transmission rate. And these transmission rates depend very strongly on the distance between the central office and your home. And indeed, if you're too far away, generally more than about 3 miles, you can't actually do DSL to the central office. And now let's take a look at the home itself. This is what a typical home network might look like. There's a link connected to the cable modems, a router that has both wired and wireless links to devices within the home. Now, these links are typically wired Ethernet that runs typically at 100 megabits or a gigabit per second transmission rate, and Wi-Fi, which runs at tens or hundreds of megabits per second. Often the router, the modem, Wi-Fi, and Ethernet are all combined into one box. And then, of course, we've got the home devices themselves, the hosts, and the end systems that we talked about earlier.
Stop researching with ChatGPT. Its information is not reliable, and you can't use it in your paper.
Surprise.
Since we've already mentioned Wi-Fi networks in the context of home networks, let's take a look at wireless networks first. Now, all of Chapter 7 is going to be dedicated to wireless networking, so we're just going to look at the big picture here. And one way to think about this is there's basically two classes of wireless networks. There are the local wireless networks, Wi-Fi, for example, and then there are the wide area networks corresponding to 3G, 4G, and soon 5G cellular networks. Now, for both the local case, the local wireless networks, as well as the digital cellular networks, there's an entity, a base station, an access point to which the end device is transmitting data and receiving data from. Well, the first broad class of wireless networks are known as Wi-Fi or wireless LAN, WLAN networks. We've already seen these in the context of home networks, but they're also widely deployed within municipalities, with companies and other institutions as well. They tend to operate in the range of about 10 to 100 meters, if you're lucky at 100 meters, and they operate at different speeds from 11 to 54 to 450 megabits per second. These protocols are actually standardized by the IEEE